Hello and welcome to 6-1 Part 1. This lesson will be divided up into two parts. We'll talk about the basic law of signs in this lecture and the ambiguous case in another. The law of signs, in 6-1 and 6-2, we're dealing with laws of sines and cosines. Those laws are, we're dealing with triangles that are not right triangles. So, in any case, let's say that I have a triangle that's not a right triangle, and I want to find missing sides or angles based on the information that I have. Well, the law of sines basically says that if I have any two sides and an angle, or any two angles and one side, and they have a certain relationship, then I can use the law of sines to find them. So, for example, you see it says if ABC is a triangle with sides A, B, and C, then A over the sine of A equals B over the sine of B equals C over the sine of C. So what that means is, so you have C right here as your angle, and little c is your side. If you have an angle and the side across from it, and another angle, and you're missing a side, you can solve. But in the same way, you can also, if you have two sides and one angle that's across from one of them, you can find the missing angle. So we're going to write this down. We're going to apply it. I'm going to give you two example problems and then turn you loose on your assignment. Please note that this can be written as sine of A over A and sine of B over B. It doesn't matter which is on top or which is on bottom, as long as you have two angles on top, two sides on bottom, or two sides on top, two angles on bottom. The reason why you see three of them there, it doesn't mean that you need all three. It means that any angle and its opposite side can be set equal to any other angle and the sine of its opposite side. So in our first example, let's say I have this triangle, and they tell me that angle C is 102 degrees, angle B is 29 degrees, and side B is 28 feet. And I want to find the missing angles and sides. Well, the third angle is pretty easy, because all the angles of a triangle, no matter what kind of triangle it is, have to add up to exactly 180. So 180 minus 102 minus 29 is 49 degrees. So I have all three angles. Now, because of the law of sines, I can set up a series of relationships. And I can set up and say, all right, well, I've got side B is opposite of angle B. So 28 over the sine of 29 equals C over the sine of 102. Or they use sine A and sine B here. So since angle A is 49, I can say that little a is going to be equal to 28 over the sine of 29, then times the sine of 49 once I solve. And in these problems, you have to use a calculator. There's no way not to use the calculator. For little c, you can solve it the same way. It's just you're using the values of c rather than the values of b. Now you would ask, how would I set this up? So I would set it up initially. As, so 28, let's see why it's not letting me draw. There we go. I would originally set it up as 28 over the sine of 29 equals A over the sine of 49. Now, when I cross multiply and divide, that's how I eventually get the simplified formula on the right. I get 28 times the sine of 49 divided by the sine of 29. Likewise, on the right, I could set it up as 28 over the sine of 29 equals b over the sine of 102. You want to make sure your calculator's in degrees and not radians. Cross multiply and divide, and you get your answer. Okay? The only time that you're not just going to straight cross multiply and divide is if you're solving for an angle, in which case you'll have to do the inverse, the sine -1. On our next example, it says a pole tilts towards the sun with 8-degree angle from the vertical, and it casts a 22-foot shadow. How tall, the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So I've got 43 degrees here, and I've got 8 degrees here. I want to find this height. Okay? I want to find the height of the pole, which actually they're calling A here. So angle C right here, I know that this is 8. So if I subtract 8 and 43, I subtract those, I know that I have 39 degrees. I take 180 minus 43 minus 98. I get 98 because this entire angle here at angle B, if I'm looking at the entire triangle on the outsides, not the individual little triangles, if I take the entire one, I get 98 degrees for that angle and the little 8-degree one. And so when I subtract those, I get that angle C up here at the top is 39 degrees. So now I set up my law by law of sines, and I'll set up the ratio for you so you can see it. So I would set it up that since I'm solving for little a, and I have 43 degrees, and I have I have 39 degrees, and I have a length of 22 feet, I can set it up as little a over the sine of 43 equals sorry, that should be sine of 39 on the bottom. Let me erase that. So I have the sine, I'm doing that backwards, let me do it in the way that you're familiar with the side on top. So if I have 22 for C, and C is 39 degrees, so I say sine of 39 equals little a over the sine of 43. Remember, little a is across from big A, or angle A is across from, they're across from each other, and the C's are across from each other. So if I knew that this one was 39, then I can set it up like so, cross and multiply and divide, and you're good to go.